Hey guys, it's Miss Johnson, and I'm here to bring you our last notes video for Unit 4. This is Unit 4 Notes 5, where we start solving trinomial equations. So all this factoring that we've been doing, it all kind of comes to we actually take that factoring to try and solve these equations. Here's our steps for solving trinomial equations. Trinomial equations have a possibility of two solutions. So we can take each of our factors and set them equal to 0 to get our solutions. May have one or it may have no solution. That is a possibility as well, but it also has a possibility of two. So it's a little different than linear equations. We worked with linear equations a lot, where we only had one solution or sometimes none, but we would solve, we never had a possibility of two. Now we have a possibility of two solutions. And it all stems from the fact that we have that x squared involved. So when you look at a standard trinomial equation, that ax squared plus bx plus c, that's power of 2, x to the power of 2, that is where we get a possibility of two solutions. That's where that comes from. So we could have none, we could have one, but there's also a possibility of two. If we want to find the solutions, we need to set the equation equal to 0, and then we need to factor, and then set each factor equal to 0 and solve. So set the equation equal to 0 first, factor it apart, undo that multiplication, and then set each factor equal to 0 and solve from there. All right, so let's take a look. In number 1, we have an expression that's factored for us already, x plus 6 times the quantity x minus 4. So that is already factored. I've got a factor multiplied by another factor. And it's already set equal to 0, so I'm good there. I just need to take each factor and split them apart into two separate equations. X plus 6 equals 0 and x minus 4 equals 0. Once I split it, I'm going to solve each one. So subtract the 6, and I get x equals 0 minus 6, which is negative 6. Over here, add the 4. Get rid of that. X equals 0 plus 4, which is 4. So my two solutions are negative 6 and 4. And that's that. So set it equal to 0, factor, and solve. Number 2, I want to set these equal to 0 as well. I already have the whole equation equaling 0. I already have it factored apart, so I'm just going to split them. 2x plus 8 equals 0, and 3x plus 2 equals 0. Subtract the 8, 2x equals negative 8, and then divide by 2, x equals negative 4. Subtract the 2 over here, 3x equals negative 2, divide by 3, and you get x equals negative 2/3. So x equals negative 4 and negative 2/3. Those are my two solutions. Now it is okay for you to just list them separate and circle both. You will see them listed together typically if this were something like a multiple choice test. Let's take a look at number 3. In number 3, now I have a trinomial that I need to actually do some factoring in. It's already set equal to 0, so I'm fine there, but I do need to factor the y squared plus y minus 20. I'm going to factor using guess and check because of that y squared by itself in the front, so I know I need a y and a y. I also know that I'm trying to get to negative 20, but a sum of positive 1. So that means I'm going to need a negative 4 and a positive 5. 4 times 5 gives me 20. I'd have a negative 4y in the middle and a positive 5y, which would give me a positive 1. So now I can set all of those equal to 0 and solve from there. So split them apart. That's y minus 4 equals 0. Add the 4, and you get y equals 4. Over here, y plus 5 equals 0. Subtract the 5, and you get y equals negative 5. So my two solutions are negative 5 and 4. Over here, the 6a squared plus 5a minus 6. Now this is one that has a lot of options for that first term. So I'm going to go ahead and set up an x here. 6 times negative 6 is negative 36. And then I want a positive 5 in the middle. So what gives me a product of negative 36 and a sum of positive 5 is 9 and negative 4. That means I have 6a squared plus 9a minus 4a minus 6. It's still all equal to 0. Now I'm going to factor it by grouping. So that first group, I can take out a 3a. 3a out front, 2a plus 3 behind. Second group, I want them both to be positive, so I'm going to take out a negative 2 and get a positive 2a plus 3 behind, still all equal to 0. Put your factors together. So this is all that factoring trinomial practice that we did in lesson 2 and lesson 3. This is where we're going to actually take that and apply it into equations. So those are my two factors. Now I set them apart and solve. That's 3a equals 2, add your 2 to the other side, and divide by 3, I get a equals 2/3. Over here, 2a plus 3 equals 0, 2a equals negative 3, and divide by 2, a equals negative 3/2. So typically you will see these solutions listed together. I would list them as a is equal to negative 3/2 and positive 2/3. I have a habit of going in numerical order. Whatever the lower one is first, that's the one I always list. It wouldn't matter if you listed them the other way. If you did 2/3 and negative 3/2, that's fine. It means the same thing. So let's take a look at number 5. X squared minus 2x is equal to 35. So now the first thing that my eye is drawn towards is the fact that I do not have an equals 0 over here. So I need to fix that. I need to take my 35 and I need to move it over to the other side. So I'm going to subtract 35 so that that goes away. Now 35 is a constant. This is an x term. That's an x squared term. So it's not a like term with anything that's already there. I'm just going to put it right at the end where my constant would normally go in a trinomial and factor it that way. This is an x squared in front, so I can factor this pretty easily. I know I need x and x because x times x is the one that gives me x squared. And then I want a negative 35 product and a negative 2 sum. So that's going to give me negative 7 and positive 5. Negative 7x plus 5x, negative 7 plus 5 is negative 2. Split those apart. So I have x minus 7 equals 0 and x plus 5 equals 0. Add the 7, x equals 7. Subtract the 5, x equals negative 5. And there you have it. Negative 5, 7. Take a look at the next one. I have 4m squared plus 12m plus 9 is equal to 0. So this is one that, again, that 4m squared at the beginning, well, actually recognize. This is perfect square, perfect square. I can set my factors up as two of the same thing, and it was already equal to 0, so that's good. I'm going to take the square root of the first term and the square root of the last term, 2m and 3, and the middle term is positive, so I'm adding 2m plus 3. So let's just roll that back to make sure. I want to always check that and make sure that I get the right thing. So that's going to be 4m squared. Outside, first outside. Outside is 6m. Inside is another 6m. 6m and 6m is 12m. And then last, 3 times 3 is 9. So I'm good. There's my factored form. Now I got to solve it. So in all of our examples leading up to this point, we've had two solutions, one solution, two solution. Here, when I split this, 2m plus 3 equaling 0, that's 2m equals negative 3, that's m equals negative 3/2. Over here, 2m plus 3 equals 0, I'm going to get the same thing. That's 2m equals negative 3, which is m equals negative 3/2. You do not need to list the same solution twice. You only need to list it once. This is just m equals negative 3/2. This is only one solution. Whereas over here, this was two solutions. Okay, when you get the same solution twice, it's really only one solution. Let's take a look at 7. In 7, I recognize that's a binomial, so I'm going to check my terms, and I do in fact have a perfect square and a perfect square and subtraction. This is already equal to 0, so that's good. I'm going to factor these apart. That's 4x and 5. 4x minus 5. So 4x plus 5, 4x minus 5. Split those off. 4x plus 5 equals 0. That's 4x equals negative 5. X equals negative 5 fourths. Sorry, not halves, 5 fourths. Over here, 4x minus 5 equals 0. That's 4x equals 5. And that's x equals 5 fourths. So my two solutions there are negative 5 fourths and positive 5 fourths, which you will see quite frequently when you have a difference of two squares. You're going to see solutions that are the same, but one's positive and one's negative. Okay, let's take a look at number 8. In number 8, something that my eye sees right away is the fact that this is 6, 14, and 12, and I can divide out a 2. So I'm going to take my 2 out, and then I get 3x squared minus 7x minus 6 equals 0. So now I want to solve this. Think about this 2 that's on the outside. If I were trying to solve for x, I need to get rid of the outside of the parentheses first. So I would divide by 2 to make that go away. That leaves me with 3x squared minus 7x minus 6. 0 divided by 2 is still 0. So that 2 that's on the outside, since it's just a coefficient, it doesn't have a variable with it, it really didn't affect my solutions at all. All I did was divide it out, and 0 divided by 2 is still 0. Now I'm just going to factor what's left. This has a leading coefficient that's prime, so I'm going to use that to my advantage and try and guess and check here. So I want a negative 6 product, but a negative 7 sum, which means I need to have, if I get a negative 9 and a positive 2, that's going to give me the negative 6 that I need at the end. This is going to give me negative 9. That's going to give me positive 2. Negative 9 and positive 2 is negative 7. So there's my factors. Split them off. 3x plus 2 equals 0. That's 3x equals negative 2, and x equals negative 2/3. Over here, x minus 3 equals 0. Add 3 to both sides, and you get x equals 3. So your two solutions here are x equals negative 2/3 and 3. All right, so that's how we solve these trinomials and find our solutions. Now let's actually put these in some application. The thing about these standard trinomials that have a squared term, that squared term gives us any sort of um, object that leaves the ground and returns back to the earth, basically. Anything that leaves the earth and returns back to the earth creates this type of equation that has an x squared or variable is squared in it. So really applicable equations. We're going to see these equations a lot. For example, in number 9, it says a flare is launched from a life raft. The height h of the flare in the field of the sea is modeled by the formula h equals 100t minus 16t squared, where t is time in seconds after the flare is launched. Let h equal 0 and solve for t. How many seconds will it take for the flare to return to t? So the reason we get that h equals 0 is because we want it to return to the sea. If it's returning to the sea, that's where height is 0. I'm 0 feet off sea level. So I have 0 equals 100t minus 16t squared. Now, this looks like it could be a difference of two squares. It's very, very close to being a difference of two squares, but it's actually not, because this t right here is not a perfect square. So even though 100 is a perfect square and 16 is a perfect square, t squared is a perfect square, and there's subtraction in the middle, so this is different on that. So that out my def in this case, I'm going to take out a 4 and a t. So if I have a 4t out front, 100 divided by 4 is 25. T divided by t would go away. Over here, 16 divided by 4 is 4, and t squared divided by t is just t. So that's my factored form of that. The only thing I could do is take out a GCF factor. So your two factors are 4t and 25. 4t equaling 0 just means that t equals 0. 25 minus 4t equaling 0. You subtract the 25, makes that go away. Negative 4t equals negative 25, and then divide by the negative 4. Negative divided by negative is positive. I end up with 6.25 there. Now let's think in terms of context of the problem. So I'm talking about how many seconds it takes the flare to return back to the sea. Am I going to say that it's going to happen after 0 seconds? Well, no, that doesn't make any sense. The flare has to go up and come back down. That can't happen after 0 seconds. So 0 seconds is not going to be my answer. And in fact, 0 seconds is where the flare takes off. That's the time at when the flare takes off, duh, because no time has passed yet. If I look at the other answer, 6.25 seconds, that makes a lot more sense. Flare needs to leave the boat, go up and come back down and hit the water. That's your 6.25 right there. So your answer here is 6.25 seconds. And we get rid of the one that doesn't make any sense. Let's take a look at number 10. The length of a rugby field is 52 meters longer than its width. Write an expression for the area of the field. If the area of the field is 8,001 square meters of the field. Okay, so I'm looking at a rugby field. I can only assume, I don't play rugby, but I can only assume that a rugby field is in fact a rectangle. And if I am told that width here, think of this like a system. Think back to Unit 2 when we would write systems for things. The length of a rugby field is, that's your equal sign, 52 meters longer. That means I'm adding the width. So length is equal to 52 plus the width. The width is just the width. We don't have anything that's relating the width to anything else, so it's just width of the rectangle. This is another length, this is another width. Now you're also told that area is 8,160 feet. So area equals 8,160 square feet. So the first thing says, write an expression for the area of the field. If I write an expression, that means I'm looking at area equaling length times width because I'm looking at a rectangle. Well, I can't solve this for two different variables. I have to somehow eliminate that. So if you think back to systems when we would solve the system, we'd have to get rid of that L or that W somehow. Well, the good news is I know something about L. I know that L is 52 plus W. So I'm going to put that in its place. I'm going to substitute and put 52 plus W in its space times W behind it. Then I can distribute that W in there. A equals 52, oops, not 55, sorry, 52 plus W squared. So 52W plus W squared. And then the other thing that I can substitute is put that 8160 in there. So I have 8,160 equals 52W plus W squared. Okay, now I'm getting closer. Now I've got one equation variable and I can solve it. The first thing I need to do more because when things getting close to 160. So get out your calculator. You're going to have to try a bunch of things. Start taking 8,160 and divide by whatever. I started with 10, and that would give me an 816. Now, I knew that that was going to be too far apart, but I want to just start going from there. If I take 8,160 and divide by 20, then I get 408. So I'm getting closer. I need to get to a point where these two numbers right here are 52 units apart. So I kept dividing 8,160, and what I ended up at was 68 and 120. So I eventually got to the 68, which gave me 120, and these two were 52 units apart, which is good. So this is what you were looking for, and I just tried a bunch of things in my calculator, just kept typing stuff in. So then when I factor this out, I've got 0 equals W And then I want a positive 52. So W minus 68 and W plus 120. Because if I refoil that, I'm going to get back to this trinomial up here. Split those off. W minus 68 equals 0. That's W equals 68. W plus 120 equals 0. That's W equals negative 120. Now, you're thinking real world here. You're in a real world situation, so you need to consider the dimension that actually makes sense. This is 68 meters. This is negative 120 meters. Negative 120 meters does not make sense. So I know that this is the one I want. My width is 68 meters. What that means is my length is the 120. And I just got this from the original problem way up at the top when we wrote that equation at the top at the beginning. So here are my dimensions of the rugby field. Oh boy. That question involved a lot of stuff, by the way. Systems, drawing a picture using a little geometry, knowing area equals length times width, geometry there, doing a whole lot of guess and check factoring, factoring it apart, splitting it, solving, picking the right thing, plugging it back in because it's a system, having to find the other one. That's a very involved question. That's definitely one that you might want to watch to another time, at least 2 or 3 times, so that you can kind of follow along and make sure you really understand what happened there. Okay, let's take a look at number 11. It says number 11, at a pep rally, small footballs are launched by cheerleaders using a slingshot. How many seconds the football in the air before it touches the ground? Hint, H equals 0 when the ball reaches the ground. So here's the equation that the football makes when it goes up into the air and comes back down to the ground. And I want to know when it hits the ground, so that's H equals 0. Negative 16t squared plus 20t plus 6. Now, here's the thing. I see a GCF in here. 16, 20, and 6 can be all divided by 2. Here's the other thing. I don't like it when my leading coefficient is negative. I want my leading coefficient to be positive. So for my own sake, I'm going to divide this whole thing by a negative 2 because that's going to give me a positive leading coefficient. But what that also means is that everything else behind it is negative. So 20 divided by negative 2 is negative 10, and 6 divided by negative 2 is negative 3. That is the expression that I now need to factor. And because it's an 8 in the front, there's a lot of different options to multiply to give me 8. 1 and 8, 2 and 4. And I don't know, it's going to be hard to figure out if I just try to guess and check factor. So I'm going to use the X method here. 8 times negative 3 is negative 24. Middle term is negative 10. That means I want a negative 12 and a positive 2. So I don't need this 2 anymore. If I divide out the negative 2, I still have a 0. So 0 is equal to 8t squared minus 12t plus 2t minus 3. Group them off. Group and group. Pull out the GCF. This one's a 4t. So 4t, that's a 2t minus 3 and 1. 2t minus 3. So my factors are 4t plus 1 and 2t minus 3, and those all equal 0. Holy buckets, I'm almost there. Split them and solve. 4t, oops, sorry. 4t plus 1 equals 0. That's 4t equals negative 1 if I subtract that 1 over. And then divide by the 4, t equals negative 1/4. Over here, 2t minus 3 equals 0. 2t equals 3. Add that 3 over to the other side. Divide by 2, and I get t equals 3/2. So again, we're thinking real world. If I'm talking about the number of seconds it takes the football to hit the ground, it cannot take negative a quarter second. That does not make sense. So I'm going to get rid of the negative a quarter, and I'm going to keep the 3. All right, one more application question. It says the feet of gymnasts make, that's supposed to say gymnasts, sorry. Gymnasts make a vault, leave the, woo, hello. The feet of gymnasts making a vault leave the horse at a height of 8 feet with an initial upward velocity of 8 feet per second. Use the equation h equals negative 16t squared plus 8t plus 8 to find when the gymnast will reach the floor. So if I'm looking for when the gymnast will reach the floor, I again am looking for height equaling 0. Now this equation comes from some of the information that was given, but that negative 16, we saw that negative 16 up in number 9 as well, and also in number 11. So that should start to be kind of a familiar number for you. That negative 16 in front of the t squared comes from gravity. That's our constant of gravity, and that's why we have that in a lot of these expressions or equations that are using gravity, the flare coming up and coming back to the earth, the football leaving the football thing and coming back to the earth, the gymnast leaving the vault and coming back to the earth. That all has to do with gravity pulling us back down. So 16 in the front comes from. Now, if I set up this equation, it looks like 0 equals negative 16t squared plus 8t plus 8. And I notice again that there's a GCF to take out here. I'm going to divide out an 8. And even one step further, I'm going to divide out a negative 8 because once again, I have a negative 16 in front. Now you can work with the negative 16, but I don't like to. I like to make my leading coefficient positive. So I'm going to do that. I'm going to get 0 equals, I have a negative 8 out front, and then behind it, I have a positive 2t squared. Then I have a negative t and a negative 1. That's the expression that I need to factor. So get rid of that negative 8. If I divide both sides by negative 8, that's still a 0, and then this will be gone. So 0 equals 2t squared minus t minus 1. That's the expression I'm factoring. It's convenient because my leading coefficient is prime, so I'm at 2t squared and t, or not squared, sorry, 2t and t. That's going to give me that 2t squared. Now, I know that the last two terms have to be a 1 and 1. I just need to figure out where the negative is, because that 1 times 1 is the only way to get 1 at the end. I just need to put my negative in somewhere. If I have a 1t and a 2t, and I want a negative 1 in the middle, that means I need my 2 to be the negative. So 2t times negative 1, sorry, that should be positive. 2t times negative 1 is going to give me the negative 2. 1 times t is going to give me the positive 1 that adds to a negative 1. So that's just all that guess and check factoring. Again, if you want to use the X method because you know it works every time, go ahead. Split those two off. I'm going to come up here. So I have 2t plus 1 equaling 0. That's 2t equals negative 1. That's t equals negative 1 half. Okay, how about t minus 1 equaling 0? That's t equals 1. Real world application, you can't say that the gymnast is going to be in the air for a negative half a second. Negative half a second does not exist. So I get rid of that one, I keep this one, and my answer is 1 second. Oh boy, so that takes us to the end of our solving trinomial equations video. Thanks for listening. Make sure you go back and listen to those things that you need some extra help on or you missed or you need to hear again. This is a tricky lesson. It's the last lesson of Unit 4, so take your time on it and always come see me if you need questions or if you have questions. Thanks for listening. We'll see you next time.